Okay, so our last method of calculating the percentage of oxygen in the air is our most accurate and also our most precise. We're going to use a gas syringe to measure much more accurately and precisely the amount of oxygen that's there. So this is the one that is on the back of your sheet, and this is the demo we're going to look at. So I'll talk a little bit about why this works so well. So in this case, we have copper in the middle, and we are moving the oxygen over the copper as we heat it to form copper oxide. So similar to the iron one that we've just looked at, you are taking the oxygen out of the air and trapping it in a solid, in the the copper oxide powder. So your volume of gases will definitely be decreasing because you're not producing carbon dioxide like the first one. This one works a bit better than the iron one, mostly because it reacts a bit faster. So hopefully, guys, you can see the entire setup in the video. So we have two gas syringes. This one is reading at 0. You should be able to see it's cloudy because the plunger is in there. And this one is reading at 100 centimetres cubed. It's full of air. So we've got our initial volume of air. It's going to be 100 centimetres cubed. And then in the middle, we've got an airtight seal with 2 rubber bungs. And in this glass tube in the centre, you may just be able to see there's a reddish powder. It's quite hard to see. You might be able to see it with a bit of tissue behind it, so you should be able to see there's a reddish powder at the bottom. That's our copper powder that we're going to heat up and react. So the idea is that we heat this up so that it begins to trap the oxygen in the air, and then you use the gas syringe to slowly move the oxygen from side to side, and the volume of gas should go down as the oxygen just gets trapped in the copper oxide. If that makes sense. So we should get a lower volume on here. It should be a more precise volume because we've got nice divisions on here. The biggest mistake people make doing this one is they move the plunger too fast and blow all of the powder into the other syringe. So we have to do it nice and slowly. And then sometimes you melt these. This might happen, sometimes happens in the demo. You melt one of these and then it's not airtight anymore and air escapes. So let's give it a go. Let's turn our gas on. Let's start heating our copper and slowly move in the air. Now you should, guys, as this happens, be able to see a colour change from the red of the copper powder to the black of the copper oxide. Okay, so it should. And we can tell it's airtight because I'm pulling one side and the other side is moving with it, which is good. We're getting nice and hot. Let's move it this way a little bit to make sure that bit of copper reacts. But all of the oxygen moves from one side. See? This is always the problem. Our rubber catches fire. And then we push it back the other way. And hopefully we should have reacted all of our oxygen. Now you need to remember, guys, this only works if our copper is in excess to the amount of oxygen that we've got. Okay, so if our amount of copper is not enough to react with all the oxygen in the air, we're going to get a percentage that is much smaller than we should get. So at this point, we have now got 91% of our air left, okay, which would suggest 9% for oxygen, which obviously is not very likely because it should be about 20-ish. So we obviously need to heat our copper a little bit more and get a little bit more air across. Let's react a bit more of our copper. Okay, so this side we're now at 86. So that would be 14% of our air is oxygen. And once more across. Okay. So, copper is in excess by the looks of it. We have 19.5 mils of air have been used up. So our end volume is 80.5 on our equipment, which would suggest about 19.5% oxygen in the air, which is around the 20-21% you would expect to get. Obviously, the amount of oxygen varies with altitude and things like that. One thing we do need to do is leave it to cool down for a little bit, because the air is obviously hot in there right now because we've had the Bunsen burner underneath it, and that means it will occupy more space. So we might find that it actually gets closer to the 20% shortly. So I'm going to pause the video, let it cool down a bit, and we'll take the final reading. We are very close already. Okay, so I have left it for about 5 minutes to cool down. And hopefully you can see that we are just below the 80 or the 20 mark. We're about 21%, which is what you would expect for oxygen in the air at sea level. About 21% of dry air should be oxygen, give or take a little bit. Any problems? You know where I am. Bye, guys.